Algebra 2, this is Chapter 4, Section 7. This will be the second video of 3 for the series. This is going to be finding the actual inverse matrix. And here we have the formula for it. At this point, I would pause the video and just copy down the formula. It'll be easier on you. I'm not going to derive this one and show you where it came from. I'm just going to flat give it to you, and then we'll use it to work with it. So pause the video now and copy this down into your notes. Notice that the bottom part here, right here, is actually the determinant, AD minus CB. So you could also write this formula as 1 over the determinant of A times this D minus B minus C A. And hopefully you've put this together, that you are swapping the A and the D. The C and the B are the same place, but they get the opposite sign on them. And then it's 1 over the determinant, and you're multiplying it together. Notice that you cannot have the determinant be 0 because it's in the denominator. So that's one way to know if you have an inverse or not. You can't have an inverse or if the determinant ends up being 0. So let's look at a couple of these. Let's determine, basically, can we find an inverse of these? Does the inverse exist? So let's find the determinant of this. So negative 1 times negative 2 is a positive 2. And 8 times 0 is 0. So 2 minus 0 is 2. You would have a determinant on this one. That would be a yes. Okay, negative 4 times 3 would be negative 12. Negative 2 times 6 would be negative 12. And so this would be negative 12 minus a negative 12, which would be negative 12 plus 12, which is 0. So there would be no determinant on, or no inverse on that one. Then we've got the last one down here. So negative 4 times 6 is a negative 24. 8 times 3 is a negative 24. And again, you get negative 24 minus a negative 24, which is 0. So this bottom one would also not have an inverse, because the determinant would be 0. And then I've got one last one here. So 3 times 2 is 6. 5 times 1 is 6. This would be 6 minus 6. Another one where it's equal to 0, and another one where you have no inverse because the determinant is 0. So let's take, and we've got a real matrix over here, and let's find the inverse matrix using our formula. So this is A, this is B, this is C, and this one is D. So we can fill these in. We want to find the inverse of A. So that's 1 over A, and A we said was 2, times D, which is 3, minus B, which is 1, times C, which is 4. And then we want to write our new matrix. So we're going to swap the A and the D. See, it was A and D, and now it's D and A. So it's going to put a 3 here and a 2 there. And then the C and the B stay in the same position. Just the C switches signs, and the B switches signs. So this becomes a negative 4 and a negative 1. We're not done yet, so we need to actually solve this creature over here. So that's going to be equal to 1 over 6 minus 4 times that matrix, which is going to be equal to 1/2 times that matrix, 3, negative 4, negative 1, 2. And now it's just a scalar multiplication. So 1/2 times 3 is 3/2. Half of 4 is negative 2. Half of 1 is negative 1/2. And half of 2 is 1. And that is our inverse matrix down here. Now we could grab our original matrix, which was 2, 1, 4, 3, right? 2, 1, 4, 3. Did I grab that correctly? 2, 1, 4, 3. And I can multiply it by this matrix here. So I can take this 3/2 times this 2 and 1. So 3/2 times 2 would be 3. What am I doing here? So 3/2 times 2 would be 3. and negative 2 times 1 would be negative 2. And then 3 halves times 4, 4 divided by 2 is 2, times 3 is 6, so that's 6, and that would be minus 6, negative 2 times 3. And then I've got, I'm going to do the next one here. So I've got half of 2 is 1, so it's negative 1, and 1 times 1 is 1, so plus 1. And half of 4 is a negative 2, and 1 times 3 is plus 3. And you can see when we combine our terms here, 3 minus 2 is 1, 1 minus 1 is 0, 6 minus 6 is 0, and negative 2 plus 3 is 1. We did get our identity matrix back when we multiplied those two together. So we did, in fact, find our inverse, and our inverse was this one right here. Let's do one more example of inverse matrices. Okay, so let's fill this information in. So again, this is A, this is B, this is C, and this is D. So I'm going to take 1 over AD, 3 times 2, that's 6, minus BC, BC, 5 times 1 is 5. And then I need to rewrite my matrix. My A and my D are switching spots, so I'm going to put my 2 here and my 3 here. And then my 5 and my 1, my 5 becomes a negative 5, my 1 becomes a negative 1. And I want to rewrite that, so 6 minus 5 is 1, so this is just a 1. So my final answer is this 2, negative 5, negative 1, 3. And that's about all there is to finding inverse matrices.